Welcome to AplusGURU.com solution videos. Today we will cover how to graph a rational function with vertical and horizontal asymptotes using the 7 basic steps. This is the rational function that is in question right now, and I've listed the 7 basic steps on the right hand side here in the yellow box. As you can see, I've already worked out all the steps, so I'll walk you through it, how to use the 7 basic steps. Step 1 asks us to find the axis of symmetry. We simply do this by plugging in negative x for every x we see in the function, and then if the answer arrives to the original function, then the symmetry is about the y-axis. If the answer arrives to be negative of the original function, then the symmetry is about the origin. So as you can see, I plugged in negative x for every x in the function, and what ends up happening is if you do negative x squared, you will end up getting x squared in the numerator and the denominator. Therefore, the answer we arrive to is the same as the original one. So the symmetry is about the y-axis. Step 2. Step 2 asks us to find the vertical asymptotes. We simply do this by setting the denominator equal to 0 and solve for x. So in our question, our denominator is basically x squared minus 4. We set it equal to 0, and what we do is we do simple algebra where we add 4 to both sides, where we arrive at x squared equals to 4, and then take square root of both sides, so we'll end up getting plus or minus 2. So our vertical asymptote is going to be at x equals 2 and at x equals negative 2. Step 3. Horizontal asymptotes. This can be a little tricky. So there's 3 different scenarios for finding the horizontal asymptotes. If you look at it, there's this general function whereas f of x is equal to a times x to the n over b times x to the m. It looks very similar to our function in question. Now, there's 3 cases to find the horizontal asymptote. Case number 1 is where if the exponent of the numerator, the highest polynomial of the numerator, is equal to the highest exponent of the denominator, then the horizontal asymptote will be at y equals to a over b, which is the coefficients of the numerator polynomial and the denominator polynomial. Case 2 says if n is less than m, then the horizontal asymptote is at y equals 0. Case 3 states if n is greater than m, then there is no horizontal asymptotes, but there will be a slant asymptote. Now, in our question, it's basically case 1. If you notice that the numerator's highest polynomial's exponent is 2, same with the denominator where the highest exponent is 2, so our answer is going to be the coefficient of x squared of the numerator, which is 1, and the denominator's coefficient is 1 as well, so our horizontal asymptote is going to be at y equals 1. Step 4. Step 4 states to find the x-intercepts, where we set y equal to 0 and we solve for x. Okay, so in our question here, we set y equal to 0, which is the same as f of x, and we cross multiply, so we end up getting x squared minus 16, which is equal to 0. Therefore, we add 16 to both sides and then take the square root of 16. We will arrive at x equals to plus or minus 4. So our x-intercept is at 4 comma 0 because we plugged in 0 for y, and negative 4 comma 0 again because we plugged in 0 for y. Step 5. To find the y-intercepts, we set x equal to 0 and solve for y. So as you can see, y equals to 0 squared minus 16 in the numerator over 0 squared minus 4 in the denominator, which will arrive at 16 over 4 equals to 4. So the y-intercept will be at 0 comma 4 because we plugged in 0 for x. Step 6. We simply plot extra points. So we choose points that are basically not the x-intercepts or the y-intercepts or the asymptotes. So I picked 1 for x, and I plugged it into this function right here, where I ended up getting 5 and negative 5 for y. I did the same for -3 and -5. I plugged in -3 in for x, I got -7/9, and for +3 I got -7/9. For -5 I got 21/9, and for +5 I got 21/9. Now we have our extra points, so step 7 basically says to graph the function. So what we're going to do is, in this case, we will go ahead and select our graph here, and I'm going to plot our graph and plot all the points that we have collected so far. Let's see how this looks. Okay, so let me select pencil here, and what I'm going to do is I'm going to start by plotting in the intercept points. So if you notice, our intercept points at the x-intercepts were at -4, 0, and at 4, 0. So I'm going to plot that there. And our y-intercept was at 0, 0, +4. So I'll plot that over here. Okay. Now that we've plotted all our points, all our x and y-intercept points, I'm going to start drawing the asymptotes. The vertical asymptotes are at x = 2 and -2. Here we go. At x = +2 and at x = -2. And I'm going to plot our horizontal asymptote at y = +1. So that will go in this way. Okay, so we've done that. Next, I'm gonna go ahead and plot our extra points. I have -3 and -3 and -7/9, which is probably gonna be about here. And this other point at -5, 7/21/9 is probably going to be about here. Same thing, since it's symmetry about the y-axis, I simply do that. I simply reflect it over, and I'll draw this one about here. Let's see, about there, and this one about here. And I'll use our automatic graphing utility to graph this function. Here we are. Okay, so we've graphed our function, and it looks exactly like we plotted the points, and its lines are going through the points, so everything we calculated is correct. And I hope this video was actually helpful. Thank you for watching AplusGURU.com solution videos. Please visit us at www.aplusguru.com and sign up today to receive instant tutoring help from our expert tutors at our website www.aplusguru.com, where they can help you with math, English, or any of the science subjects. We also have a 15-minute free trial as well, so please make maximum use of that.